Andariki namaskaramulu. Today is the third day of our Vedic mathematics. First 2 days we have seen the basics. Now, next topic would be Shodasa Samskaramulu, and then we'll see Ramayanam, Mahabharatam, and some research topics, Puranam, and then Panchangam. This is the second month going on for our 3 months course on Sanatana Dharma. So let us start with Vande Mataram and Prarthana. We'll request Chala Chittibabu Garu to sing Vande Mataram.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malaya Jasitalam, Sasya Syamalam Mataram, Vande Mataram. Soprajosna pulakitayamini pullakusumita drumadala shobhini suhasini sumadhura bhashini sukhadam varadam mataram Vande Mataram Vande Mataram.
Vande Mataram.
Vande Mataram.
ధన్యవాదములండి చల్లా చిట్టిబాబు గారు. Now let us request Satyaji to chant Prarthana.
Namaskaram. Let's do meditation for a minute. Gananam tva ganapatigum havamahe kavim kavinamupamashravastamam jeshtarajam brahmanam brahmanaspata anasrunvannotibhis sidasadanam. Om Shri Mahaganadhipataye Namaha. Om Prano Devi Saraswati Vajebhirvajinivati Dhinamavitriyavatu. Om Shri Mahasaraswatyai Namaha. Guru Eva Gati Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave. Na Guru Paramam Shashirasmi Guru Matirasti Guru Mama Pahi Guru. Jnananandamayam Devam Nirmalaspatika Krutim Adharam Sarva Vidyanam Hayagrivam Upasmahe Shruti Smriti Purananam Alayam Karunalayam Namami Bhagavat Pada Shankaram Loka Shankaram Shankaram Shankaracharyam Keshavam Badarayanam Sutra Bhashya Kruto Vande Bhagavanto Punah Punaha Ishvaro Gururatmeti Murti Bheda Vibhagine Vyoma Vadyapta Dehaya Dakshinamurtaye Namaha. Asato ma sadgamaya Tamaso ma jyotirgamaya mrityorma amrutam gamaya. Om Shanti Shanti Shanti. Matrudevo Bhava Pitrudevo Bhava Acharya Devo Bhava Atithi Devo Bhava. Om Sahana Vavatu Sahanau Bhunaktu Sahaviryam Karavavahai Tejasvinavadhitamastu ma vidvishavahai. Om Shanti Shanti Shanti. Sri Guru Bhyom Namaha. Harihi Om.
ధన్యవాదములండి సత్య గారు. Okay, now let us request Goutham ji to start the webinar.
Gautam ji, your net is unstable. Now it's okay.
Good morning. Namaskar. Sabhi ko namaskar.
Yeah, your net is unstable, Gautam ji. The video is flickering very. PPT is okay. You can switch off your video in case you are finding a problem. You can switch off your video and talk. Yeah.
So, yesterday we were discussing about we completed the Nikhilam method of division, that how it can be evaluated in one step or sometimes two steps, and gradually when the divisor becomes away from more and more away from the nearest 10, it starts getting complicated. Therefore, I commented that there can be there is another method, state division can be the solution, or the conventional division as we learned, that is also well and good. I will have a letter I could not prepare. There is a comparison between these two, that how the conventional division actually uses the repeated subtraction and trial and error method, and repeated subtraction, say 3,000 times subtraction first time, 800 times subtraction, and so on, digit by digit, and finally it arrives at a particular remainder, and of course the process gives the quotient. And in this case, what we do, we passed with nearest 10 power, we divide, and thereafter the deficiency we keep on adding. Deficiency, contribution coming out of the deficiency, we keep on adding in every 10,000 and 1,000 and so on, every part of the powers of 10. Then we came to another one, that if there is a sub-base technique. Suppose instead of I am giving to divide by 23, I divide by, instead divide by 92, and then after the result is obtained, it comes to 92 into 10, 920, plus 91 if I add, it becomes 1011. So it is actually, this is the result of 92, division by 92. But we are dividing by 23, so the quotient will be 4 times, obviously, to start with. But remainder, if it is more than the original divisor, it will be, again, you have to do some calculation to find out the final quotient and remainder. Now we come two cases where to correct maybe some reinstallation is required. I have to now I go to it was below the tens power. Now we go to above the tens power. I'm switching off the video, and it requires I will do after some time.
Right.
Now we are coming to below. We had been discussing below tens power and slightly above tens power. Say 112. 1, 2, 3, 4 by 112. Again, I do the same thing. Put a draw a line. Had it been divided by the nearest tens power, that is 100. 12 had been my quotient and 34 as remainder. Here, there is a trick. We are calling it deficiency as earlier, I am writing it, but it is in vinculum. Vinculum I am writing not always vinculum on the top, but digit by digit if I write, sometimes I can write this way also. That's negative. These numbers are known to us. Now, -1, -2. Again, the same thing earlier we did. So, although it is procedure is same, but it is called transpose and apply. Paravarta method, not Nikhilam method. It's Paravarta method. Now, this again 1 into -1, -2, which -12. 1 into this -1 comes here and -2 comes there. 2 minus 1 is again 1, and 1 into -1, -2 again -1, -2. Finally, we add 4 minus 2 is 2 here. 3 minus 2 minus 1 is 0. 12 minus 1 is 11. So obviously it is expected. So 1, 2, 3, 4 when divided by 100, we are given 12 as quotient and 34 remainder. Obviously, if it is more than some divided by more than 100, it will be obviously less quotient. So as expected, it is there. Again, another problem. 13,456. So it is divided by 1,123. Again, this 1, 2, 3 was extra above the nearest power of 10, that is 1,000. So it's -1, -2, -3, or -1, 2, 3, or 1 vinculum, 2 vinculum, 3 vinculum. The writing style is different. Again, I do the same thing. 1 into this -1, -2, -3. Right, like this. In fact, you can use, if you like, you can use the vinculum also. Actually, as I told, the writing out vinculum in computer is difficult. In book also, it is given as this one. If you purchase the book, no problem. It doesn't matter how you write. Now, this is also -1, -2, -3. Again, 3 minus 1 is 2. 2 and this -1, -2, 3 is -2, -4, -6. 6 minus 6 is 0. 5 minus 3 minus 4 is -2. 4 minus 2 minus 2 is 0. And 13 minus 1 is 12. This 0 minus 2, 0. Actually, this gives, yes. And this gives a different thing. You have to write, think over it. This quotient, there is something negative in the remainder. That means what? That means 1123. You have to write that. Quotient is negative. That has significance. This was 1123. Now quotient is negative. I'm sorry. This remainder is negative. So quotient is something 12, and 12 is here, and the remainder is negative. That means remainder should have been less. I mean, quotient should have been less. So I subtract this 20 from here. and 1103. So minus 20 is in my remainder. That means that one more 1123 has to be extracted out of the quotient that we have declared. We have declared the quotient as 12. And as I declared the quotient as a higher quotient, I got remainder, which is my negative. So one more this dividend has to take out from there. So it comes 11 as quotient, and that negative of that negative 20 is adjusted with the divisor and gives the final quotient as 1103. Is this part clear? These examples are being given so that at that time of evaluation, sometimes you get like that. But there are some expressions I got, get like something being coulomb, something negative somewhere. So every time, what is the meaning of that being negative? Is this part clear? Or should I repeat?
Yes, it's clear.
It's clear. So initially, out of this process, out of the whole of this process, I got 12 as my quotient, but remainder I got negative. That means my estimation of the quotient was higher. So we have to reduce the quotient. So when I reduce the quotient, one divisor becomes contributed to my remainder. And remainder was already minus 20. So when I contribute one remainder, 1123, it gives 1103 as my final remainder. Is it clear? Come to next. Divide 2, 3, 4, 5, 6 by 123. How I do it? Again, 2, 3, 4, 5, 6 by 2, 3, 4, 5, 6 by 123. So again, going minus 2, minus 3, and then this 2 into. So in this particular digit, this 2 is there, and minus 2, minus 3 will be contributing to minus 4, minus 6. And out of this, at this particular location, it is a 10,000 location, there will be contribution of minus 2, minus 3 as minus 4, minus 6 in the thousands location. So this 3 minus 4 becomes minus 1, because of which this becomes positive. See, minus 1 into minus 2, minus 3 becomes 2 and 3. And again, 4 minus 6 plus 2 is 0. And because of this 0 and 0 are contributed. So again, 6, 5 plus 3 is 8, 4 minus 6 is 0, 3 minus 4 is minus 1 and 2. And so 2 minus 1, 0 becomes my quotient and 86 remainder. So 2 minus 1 is the vincular notation, it becomes 190. 2 minus 1 is 1 vinculum is 19. So 190 as my quotient and remainder is 86. Different kind of examples. This is also another technique. Paravarta method is called, so it is not always Nikhilam, always cannot be by above 10's power, it is below 10's power as well. So 4009 by 8822, 4 and 009 because it is nearest 1000, so 1000 we divide. And 118 as earlier in Nikhilam method, this is the difference between 1000 minus this 882 is 118. But here we use another technique. Instead of 118, I convert it into vinculum. 1, 2 and minus 2. This kind of. Again, I do the same thing. 4 and 4 plus 8 minus 8. So when I multiply this by 4, it becomes 4 plus 8 minus 8. 9 minus 8 is 1. This is 8, this is 4, 4. So my quotient is 4. Remainder is 481. Is an easier example. Had I KFC in the Nikhila method 118, it would have been very large numbers, 72, same thing, doesn't matter. But it looks more clear, straightforward kind of thing. Here another some special cases came. So so far these things are clear. These examples.
Sir, I have a doubt, sir.
Well,
Yeah. If we take the same example as you have taken here, 1, 2, 3, 4 divided by 1, okay, whatever it is. So in that case, we have taken that 12 excess, so -1 and -2. So, and we are doing whatever the process only with the first digit -1. So what if, so the same is even with, if the divisor is 113 also, the same answer will come, 114 also the same answer will come, right? Because we are doing, we are doing only with -1. We are not touching the -2 part. So -1 times 1 is -1 and 2 minus 1 is 1. So 1 into -1 is again -2. So we are doing only with only the first digit, -1.
No, examples, here I took another example, here it is 2. 2 is multiplied by -2. There is no -1 here.
Yeah, okay. In this case, we are taking only -2. So we are not taking we are not using -3 part anywhere. So we just took -2.
No,
so
-3, everything is being used. All the digits are being used. This is -1, this -2. This -1, -2, -3. All these things are being used. And this 3 minus 1 is 2. 2 multiplied by this thing, -2, -4, -3. All these things are being used.
Okay, sir. Sorry, I think I just caught it in the wrong way, probably then. Okay, sir. Thank you. Yeah.
Everything is being used. Here also these things are used. This also. Now this is clear now, everybody? Everyone? Yes. So I come to another some special case again. So far we did only with above 200, starting with 1 always. So always with 1, this is also starting with 1. What happens is something starts with 2. So sorry. Divide 2699 by 224. So again I do the same technique. Instead of 224, we divide by 112, means half of that. And 112 we already know, -1, so to do -1, -2. So forgetting about 224 for the time being, we keep dividing 2699 by 112 by the procedure that we learned just now for our method, or the opposite of Nikhilem method. So it becomes -1, -2. 2 here is here, so -2, -4 it becomes. Okay. Then 6 minus 2 is 4. 4 into this one is -4 minus 8. So this gives it gives 11. This adds up to 1. This also adds 1. This adds up to 24. Now we divided by half of that. So, and we got a quotient. So if we had it been divided by double of these things, when 224, our would be even half of this, the quotient will come, obviously. This will be 12 as quotient. We again divide by 2. It becomes 12 quotient. So the thing is that 112 into 24 is equal to 224 into 12. So therefore, quotient is half of that, but the remainder is not affected. Remainder is not affected. So earlier, what happened? We in one case, we divide something by 4 times of that. Remember the 20, instead of 23, we divided by 92. 4 times of that. So it can happen that the remainder is less than, remainder becomes more than the actual divisor. But here it is not the case, because here it is, obviously, if it is less than the modified one, which is half of that, divided by 2, already it is below that. So we have obviously it will be below that. So there is no problem will come about the remainder. So only thing that you have to make the quotient half. This challenge may come when dividing. Divide 1/6 the whole line by 223. Earlier it was 24, now it is 223. We divide by 2, it becomes 111 and a half. So this is very peculiar. You have to be very attentive to listen all these things. And our this Paravarta method, -1 minus 1.5. How to handle 1.5? We keep 1.5. We handle as if it is keep handling 1.5 as it is a number 1.5 and so on. So we proceed like that. So 1699 -1 and -1.5. So this becomes 5. 5 multiplied by -1 is -5. 5 multiplied by -1.5 gives -7.5. When we add these things, 9 minus 7.5 is 1.5. 9 minus 5 minus 1.5 is 2.5. And 16 minus 1 is 15. We divide by 2. We divide by 2. It gives me 7.5. And remainder, so 7.5 is the quotient, and remainder 2.5, 1.5. With when I divide by 111 by half. So when I when I divide by 200, when I divide by 111 by half, it was 15 and 2.5, 1.5. But when I divide by 112.5, the quotient part gets affected, changed to 7.5, but remainder remains as it is 2.5, 1.5. But now, what are the meaning of these halves? What I do? This half in quotient means half of the original divisor. You understand? Half in a quotient means half of the original divisor. So another 1.5, half of this 1.5, 111.5 is contributed on the remainder side. And this 2.5 in tens digits means 25. Plus this 1.5 all added to becomes 138. Now it is clear number or on the integers or no number. Now question, any question from this technique?
So can you explain how 25 came there? Once again,
Yeah.
please?
See, anyway, had it been say 2, means value is 20, it is in tens position. Had it been 3, it is 30. So now it is 2.5, why it's not 25? It is in tens position. No, this is in each position, this is tens position.
Okay,
In each position, 100, and this tens position 2.5 means 25.
Okay.
10 into 2.5. Clear? This was more challenging. Understanding this. This is okay. Remainder, whatever comes here, half. Sorry, but this is to be understood, interpreted more clearly, that quotient side half means half of the original divisor. This comes here. So presence of half equation will contribute half of dividend. No. Divider. I'm sorry. Okay. Clear now? There's a mistake.
Yeah, you can go ahead.
I said now, yes. Enough time for another topic to start. Now, so far you have seen division of a dividend by a divisor to yield the quotient and remainder. Okay? It is E is equal to D into Q plus R. So we divide E by D and we express in that format D into Q plus R, or E by D is equal to, we do Q. We didn't go so far to this part. So far we are only satisfied with this. We had a dividend and we divide by something and come out of a Q and R. Now, when you divide by D both sides, it becomes E by D is equal to Q plus R by D, and R always becomes D. That is the definition of a remainder, that remainder is the one which must be less than the dividend, otherwise one more percent would have come. Okay. Depending upon requirements, division may be left at finding Q and R only, or we may have to express it in the form as shown above up to R minus D. And then we may express fraction R by D into a decimal form. For example, this. We can write like this one also. 15 divided by 4, Q is equal to 3, R is equal to 3, or 15 by 4 is equal to 3 into 3 by this form also we can write 3 full, 3 and 4, or we can express as 3.75 as we require. So mostly for an expression E by D where E greater than D, it can always be expressed as a whole part plus a fraction of the form N by D where the numerator N is less than the denominator D. When we do like this, we do not call it R by D, we do not call it remainder, but we call where it is less than the D part, it's called N. And it do not do a divisor, but called denominator. So in the fraction, N by D means normally N is less than D and called numerator by denominator. This particular form. You all know this, just revision. Any rational fraction of the form N by D becomes a terminating decimal. Now these challenges are the property of the decimal now comes. Now you are interested in decimal only, not the fractional form. We are interested in decimal. So we know that N by D becomes a terminating decimal when the denominator is purely comprising of factors of 2 and 5. Because the decimal system, the factor decimal, our base is 10, and it has 2 factors, 2 and 5. So therefore, 2 and 5 is a special treatment or special behavior. So they display special behavior. Maybe my light is some creating problem. Light is less or something like that.
It is not light, it is the bandwidth, the signal strength. So to switch off your video, don't worry.
Oh, sorry. So this you understand, no? All no lights nicely. Something is. Am I audible nicely?
Yeah, you are audible. Audio is okay.
Now, purely since that, as I told, I repeat the part. 10's power. Our base is 10. So it comprises 2 factors, 2 and 5. So 2 and 5 display separate behavior than others numbers. So the N by D becomes a terminating decimal when the denominator is purely comprising of factors of 2 and 5. So for example, half is 0.5, ends there. 1 by 4 is 0.25, 3 by 4, 7.5, and these are all the examples are given. Similarly for powers of 5. So always they have determinants. Determinant. A rational fraction whose denominator d ends in 1, 3, 7 or 9 becomes a recurring decimal, purely recurring decimal. Example, 1 by 3 is 0.3333, it independently goes. 1 by 7 is 0.142857, the 142857 block repeats. And therefore, in the next cycle, I put it slightly smaller font. So 142857 is 6 digits, is 1 by 7 characteristics. Here also it could have done. 1 by 11 is 0.09 and 0909 and like this. 8 by 13 is 0.615384. Thereafter 615384 repeats. It has 6 length, 11 has 2 length, 3 has 1 length, and so on. 7 has 6 length. This also will, length of the recurring will come later. But when a rational fraction, other than those two previous categories, will have a non-recurring part in the beginning, followed by a recurring part. How? 1 by 6 is 0.1 and then 6666. 8 by 15 is 0.5 and then 3333. 9 by 14 is 0.6, then 428571, 428571, and so on. 26 by 75 is 0.34, thereafter 6 repeats. And 48, 35 by 48, 0.729, 7291, then 6666. And 77 by 300 is 0.25666. Length of the non-recurring part, there is a formula for that, will be the greater one between the maximum powers of 2 and maximum powers of 5 present in the denominator. I explained this part. Maximum power of 2 in 6 is what? 2, 1. And the power of 2 is 1. So there will be 1 recurring decimal. Here, there is no power of 2 here. Power of 5 is there. It is 3 into 5. So power of 5 is 1. So it is comes to what? 5 to the power 1. 3 into 5 to the power 1. So only 1 digit comes. Here also 2 into 7. So 2 to the power 1. So only 1 part. Here it is 3 into 25 means 3 into 5 square. 3 into 5 to the power 2. So you see 2 came here, 3, 4, and then after repeats. Here is 16 into 3. 16 means 2 to the power 4. 1, 2, 3, 4. 7, 2, 9, 1. 4 digits came, non-recurring part, and then recurring part. Here 3 into 0, 0. It is 2 to the power 100 means actually 2 to the power 2 into 5 to the power 2. So therefore 2 came. Maximum power of both the same thing, it is 2. So it is came here. Any question? Recurring behavior? Any question from this recurring behavior anywhere? Clear?
Yeah, in this 2 to the power of 1, the first example, 1 by 6. See, we are saying 2 power of 2, but in 6, the 2 square can come, right? 2 square is, so power of 2 is 2.
No, 6 is 2 into 3. And we have to factorize now.
Oh, okay.
Here? Now, maximum power of 5, yes.
Oh, okay, got it.
If a fraction of third type can be easily transformed by multiplying both numerator and denominator by either a power of 2 or power of 5 in order to neutralize D. Now, fraction n by d transformation. So how we do actually? How actually logic? How to understand these things? This we discussed earlier. This mixed kind. Now, what is the logically? What is the transformation by which we are getting this recurring part and non-recurring part and recurring part? It is being shown here. A fraction of third type can be easily transformed by multiplying both numerator and denominator by either a power of 2 or by power of 5 and neutralize d. So 1 by 6 becomes 5 by 30. So it's 1 by 10th of 5 by 3 and 1 plus 2 by 3. That means this is this actually it becomes this 5 by 3 and this has become opposite actually. 5 by 3 is transformed into 1 plus 1 whole and 2 by 3 divided by 10. So it becomes 1 gives actually this is 1 gives this 1 and 2 by 3 give pure recurring of the second kind I told 1.666 and which whole thing is divided by 10. Therefore, this 1 is coming. The non-recurring part is coming 1 and then 666. That basically the non-recurring part results from a whole part and the recurring part from the fraction of second time. That is denominator ending in 1, 3, 7 and 9. More example, 29 by 74. This when I multiply it by 5, it becomes 145 divided by 370. So 1 by 10th of 145 by 37. 145 by 37 is 3 whole and 34 by 37. Whole thing by 10. So it is 0.3 plus anyway, I corrected later. It is actually bracket is here. So 0.3 plus 34 by 37 by 10 is whole thing should be in bracket. I assume this bracket should have been here. This whole thing should have been bracket. I'll correct it. 0.3 and then this 34 by 37 is 0.98, 918, 918, 918 and so on. And by the whole thing divided by 10. So 0.3, 918, 918 and so on goes on. Okay, clear? I'll correct it later. You just you'll get it correct. 29 by 75. It is multiplied by 4 because there is a 5 square is there involved here. So 2 square I have to multiply 2 in order to neutralize this denominator. So that becomes 300 in this case, 160 by 300 into 0.1. So 0.01 obviously it is by so it is into 0.01. 116 by 3, so 0.01 into 38 whole and 2 and 3, 2 by 3. So 0.38 plus no, this was not bracket. This was also 0.3. I already cleared it. This is by 10. So this 0.38 and 0.01 into 0.666, 0.3866. Clear? Any questions from here? No. Bracket. Or I was mistaken. And this is all correct. No problem. I don't have to correct anything.
Yeah. There was no requirement. So, yeah.
I have already worked it out here.
Right.
Sorry.
Okay.
So again, I repeat here, 3 plus, okay, if you understood, 3 plus 34, 7 by 10 becomes, we worked it out already, 0.3. We have taken already the decimal point, 0.3, and then 34 by 37 divided by 10, So 0.3 plus these things by 10, this means 0.3, and this 1 decimal 0.6 because of this divided by 10, 0.39181. You understand? This correct? Now this is also this one 0.0133, 0.38, again 0.01 into 0.66 is 0.56. Any confusion in your head?
Yeah, you can go ahead.
Or decimal to fraction is the opposite of that. How we do it? Decimal to fraction. For terminating decimals, denominator becomes 1 followed by, for terminating decimals, denominator becomes 1 followed by as many zeros as the number of digits after decimal point. Then write in minimized form if required. So 0.125 is 125 divided by 1000, so 1 by 8. 5.48 divided by 100, all we know, 137 by 100. For pure recurring decimal, put as many 9s as the denominator as the number of digits recurring, then minimize. 0.333 becomes 3 by 9, 1 by 2. 0.4545 4599 divided by 500, 4545 divided by, there are 452 parts, 99, as many 9s as this thing, so become 99, so 5 by 11. 142857, 142857 repeating. So 142857 divided by 6 numbers of 9, which is actually, if we work it out, it will become 1 by 7. Clear? Now, problem comes when there is a mixed kind of decimal. Mixed kind of decimals, the denominator put as many 9s as the number of recurring digits, followed by as many zeros as the digits, the number of digits fixed. On the numerator, subtract the fixed part from the total. So 0.1666 becomes 16. We take the 1 and 6 also. So 16. And then subtract by the recurring, non-recurring part, equals 1, 16 minus 1. And put as many as the recurring part first. Recurring part was 1, so it's also 9, and non-recurring part is also 1, so 0. So 15 by 90 is 6, 1 by 6. 0.6818181. So 681 is my, I have taken minus, I do minus 6. And do, as numbers of recurring was 2, 81. So 99. And only 1 6 is there in the beginning, which is a non-recurring. So put 1 0 for the non-recurring. Then 675 by 992, 15 by 20. 0.153 323, 1.15 323 and so on. So 1533 minus 15, so 99900 15308 Now, interestingly, suppose you commit a mistake, so you do not detect that, you may get confused, no? Instead of 1532333, suppose you take 153 as a non-recurring part, and 233, 233, 233, it goes like that. Even then, the result will not differ. Even then, the result will, you can do, I didn't do it, but you just work it out, as take as a task. Okay, you note down, please note down. That suppose, here it is, you understand, everybody understood what I'm telling? 1532333 like this is going on. But suppose by mistake you tell that 153 was my initial, and then 233 is recurring. So here I will do a different calculation, whether it comes out with the same result or not. So please take this task and tell me. Okay. Now finding decimal expression in the Nikhilam. We in the conventional division we do something. What we do in conventional division? Suppose I am asked to express as a fraction as a decimal. What we do? We keep on adding zero, isn't it? We keep on adding zero. Put a but the starting of adding a zero becomes how do we do it? We start adding by zero by putting a decimal point. So when I put a decimal point, I am permitted to add a zero. Remember that we did? And then you keep on adding as if it is another number, and we keep on dividing and keep on evaluating like that. In Nikhilam method also you can do like that. Like in conventional method, we can do also by Nikhilam method that I have shown here. But it will not be interesting. That just to show you that how it can be done. And 3 and 0 was that by 2 divided by 2. So it is it becomes 2 into 3 is 6. So it becomes 3 quotient and 6 remainder. Now we want to do further on decimal. So we put a 0 here again. Now when 8 this 2, when you 2 multiplied by 6, it becomes 12. That 12 comes here. So again 12 minus 8 is 4. So 6 and 12 becomes my 7 and 4. 7 and 4. Again we got 4. This 4 I am dividing by 8, so it becomes 2 into 4, it becomes 8. That way it actually, if you practice, you find that. So actually 30 minus 8 will become 3.75. We can do it. I only wanted to show you that how it can be done. That's all. It's not very. So I did it fully. I did it 22 divided by 7 by Nikhilam, and came out to be 3.142857. Came like that. No problem. Like in conventional mathematics, I can do it. No, we do always. Anyway, you all know it, so it doesn't matter. But actually, that most importantly, it is this decimal expression in Nikhilam. And I did another question, say 89, 42 divided by 89. And then put a 0 here and I did it and so on. It came like that. So these things are there. So now I have comment. Recurring decimal, Vedic one-line method. I come to that point now. Calculating a fraction like 1 by 19, 1 by 29, 1 by 49, etc. are quite long and cumbersome both in the conventional division method and Nikhilam method. Vedic one-line method arising from the sutra Ekadhikana Purvenam is easy, having more than one ways, and it reveals further properties of the fraction such as cyclic property and nines complementary behavior, all these things behavior. Vedic one-line method is direct application, directly applicable for denominator ending in 9. Let us start with fraction 1 by 19. I'm coming to that, but here any questions were there?
My own, good morning. My question is that how better it is and how fast it is when compared to decimal number system division by logarithm methods. There are tables were given, and if you take a decimal and compare with logarithm, immediately you can find out the subdecimals in that. Then why we should use Nikhilam method? I don't know, because I am coming to a basic question. So
Your audio is not fully clear. Please again repeat.
are already available, tested and proven. I know Vedic mathematics also tested and proven. I'm not against. And one more thing, sir. My question is, when why should we deal with Arabic numbers? Why should not we deal with Devanagari numbers or Devanagari system of mathematical calculation for Nikhilam or for the Vedic mathematics?
No, these all can be done by your own numbers. Own number. You can do it. Same thing can be you can do by Telugu numbers. No problem.
Not Telugu numbers. When we talk of Vedic thing, we should forget about Telugu numbers. Numbers are Arabic numbers only in Telugu also. What we practice as per our education system is Arabic numbers. Correct?
No, these are not Arabic. That's what in beginning I told. It's not actually. This is Arabs got it from India, so therefore it is Indian number very much.
Murthy garu, please let us don't. I mean, as such, this Vedic mathematics is you have to concentrate and understand. So let us not digress from what is being taught. Let us not get into other complications. Try to understand what is being said,
Exactly.
and we'll have discussion on a separate date. Okay? Let us not digress from the present what is being taught.
Okay.
Concentrate, please.
Others, I understood.
Let's stop here and let's concentrate what is being said.
Yeah.
Okay. Thank you.
So any questions of all these particular topics about the decimal form, purely terminating, then purely recurring, then comes mixed non-recurring part and recurring part. Then there are conversion to fraction and I mean conversion this way, the logic this way, and then the opposite of that, decimal, the two fraction form, their procedures in case of terminating, purely recurring, and mixed kind of decimals. Any questions out of these things? And then we all know how what to do with when you want to do this evaluating the decimal point by division method. We're putting zeros every time and put zeros numbers. And this I have wanted to try that whether everything could be done by again by Nikhilam method in the same fashion. Now the questions come about the recurring decimal. Suppose I am asked to divide 1 by 19. Oh, sorry, my audio is clear?
Your audio is okay. Audio is okay.
I am asked to do divide by 1 by 19. So you remember how big it will be? It will have 18 digits. It will have 18 digits. These are actually 1 by 19 is, I did it, these are done by Excel sheet. So they will just directly dump from Excel sheets are that. I'll come to the procedure. 1 by 19 is, if I calculate it.
Excel display letters very small. To see.
Very small, no? Yeah. Okay. 1 by 19, I'll show you. But 1 by 19 is this one. 0.052631578947368421 421. These things got shifted actually. I have to correct it. And that is the thing. Okay. I'll come to that. So this from 0 to this 1, 18 digits. Total length is 18. So you will not have patience to evaluate 1 by that thing. I'll just show you in the blank place. So I do 1 by 19. You tell me what to do. I write a point here. Put a 0. It doesn't go. I put a 0. Another 0. 5. It becomes 95. Okay. Then 5. Then and put a 0. So 9, this is 2. 38. 12. Kindly switch off your. Then it becomes this actually 6. This one, okay, this way. It goes like that. But this will be again this will go to like that. 18 digits. Then it will recur. You'll understand that after that it becomes recurring. Okay, we know that, no? So this is going to different procedure called Vedic online method. So these all will give this kind of properties that calculating fraction like 1 by 19 and so on are quite long and cumbersome with both conventional division as well as Nikhilem method. The Vedic online method arising out of the Sutra Ekadikana Purvena is easy and having more than one ways, and it reveals further properties, more than one ways, left to right, right to left, and it reveals further properties of the fraction such as cyclic property and nines complement behavior. And Vedic online method is directly applicable for denominators ending in 9. Let's start with the fraction 1 by 19. Now, this is Vedic online method. Instead of dividing 1 by 19, we should start dividing 1 by the digit divisor. For digit divisor, how it is calculated? Is d plus 1 divided by 10, but in a special way. This comes from the Sutra Ekadikana Purvena, meaning 1 more than the earlier. Here in 19, earlier to 9 is 1 and 1 more than 1 is 2. So that we start dividing by 2 like this. Put the decimal point. Now 1 divided by 2, we do not directly call it 0.5. No, not this way. In a special way I told. So the result in quotient becomes 0. We put that 0 and remainder is 1. In the result line, we put Q as 0 and this becomes 0.0. Put 1 below, a little left. Like this. I'll show you a blank screen. So when I get 1 by 19, I actually do 1 divided by 2 I do, but in a special way. And therefore I write also the special symbol, other symbol. Okay, now 0 point, I do not write equal to. 1, when I divide by 2, my quotient is how much? 0, and remainder is 1. We always do by quotient and remainder. Clear? Now use this remainder as a tens digit. So for the next division. it becomes 10. So 10 is divided by 2 is always dividing by 2 is 5 with no remainder. Remainder 0 or no remainder. Remainder 0. This 5 divided by 2 becomes 2 as quotient and 1 as remainder. While dividing by 2, you get either no remainder or you get 1 remainder. Okay. So 12 divided by 2, 12 divided by 12 divided by 2 is how much? Please tell me. The others also tell me.
6, 0.
6 and 0. Oh, 0 you need not write always. 6, it becomes 3. Now 3 becomes
1, 1.
1 quotient, 1 remainder. This is 11 becomes
5, 1.
Yes. So as you proceed, you will find that you become faster. 5, 1, and then
Now others.
7,
Yeah.
7,
7.
and
7,
reminder 1.
1. Yeah. Then
2, 8, 8
8.
and 1.
8 and 1.
9.
9. So actually there is no space here. I will do that below. It's continuation, okay? 9. Then after 9 is what you find?
4 and 1.
4 and 1.
Then 7.
7. No remainder.
Yeah. 3 and 1.
3 and 1.
6 and 1.
6 and 1. Now, pardon me, you are a participant or you are one from the team?
Participant.
You are participant. This is most welcome because more new voices, new participants come. That is ideal.
8.
Now please.
8 and
No remainder.
then 4.
4. You do also side by side with pen and paper.
Okay. 2.
2. On everyone, I'm telling you all that. 2 after that 1.
1.
Then
Again, it goes back to the same repeating.
again it goes back to the 0, 5, and so on. Everything same thing. It goes back to that one.
Oh, okay.
So this is the thing. Is it not easy?
Yeah, very interesting actually. Extremely interesting.
This is quite easy. That always I get the reaction. It is only your practice. But now, certain things I see very interestingly find that. Purposefully, I put this this one halfway this way. This is I knew that the 1 by 19 will have 18 digits. Now, after 9 digits, I put it. I told that there is no space, but I put it below that. But there is the interesting behavior you see. 0 plus 9 is 9, 5 plus 4 is 9, 2 plus 7 is 9, 6 plus 3 is 9, 3 plus 6 is 9, 1 plus 8 is 9, 5 plus 4, 7 plus 8, 2. Everything is 9. So we could have done halfway and then subtracted everything from 9. This could have done also. On the other hand, another procedure we did from left to right. Another procedure can be done. This is 1 by 19. We start with 1. We start with 1, multiply it by extreme right, start with 1, multiply it by 2, it becomes 2. Okay? Something is happening when not. We start with 1, multiplied by 2, again multiplied by 2, multiplied by 2, again multiplied by 2, it becomes 16. 6 we put and 1 as a carry. Now, you do 6 into 2 plus 1, 6 into 2, and the carry we add 13. 3 put here, 1. So again 3 into 2 plus 1, 7. 7 into 2, 14. 4 into 2 plus 1 is 9. 9 into 2 is 18. 8 into 2 plus 1 is 17. 7 into 2 plus 1 is 15. 5 into 2 plus 1 is 11. 1 into 2 is 3. 3 into 2 is 6. 6 into 2 is 12. 2 into 2 plus 1 is 5. 5 into 2 plus this 0 is 10. And 0 into 2 plus 1 is 1 again, and so repeat. So this is, I understood that this is my starting point. So both way I can do, I did with left to right, same thing can be done left to right to left, halfway with 9's complement. 3 way we can do. Also, I will discuss in my course that any other things can be done. Suppose I was asked to do, pointer of strength, pain. I am now asked to do, tell me, suppose I was asked to do 5 by 19. So I want to evaluate 5 by 19, instead of 1 by 19, 5 by 19. So I start with 5 and divide by 2, isn't it? But I have already done it. I did see 5 came somewhere here. I will get 0.2631578. Suppose I want 13 by 19. 13 by 19. 13 is already there here. So it will be 0.6842105263 and comes back here. Just next one. From here, starting from here. You have to do 13 by 19, it comes from, you cannot go back to that. I'll discuss to that one. So, I was here. So here I was doing this thing. So basically what we did, successive quotient and remainder in the form R by Q are as follows. From beginning of 1 by 19, remainders are written left in small. So we did like this. We wrote like this, isn't it? 0.0 and 1, 5 and 0, 2 and 1. Everywhere these zeros are written everywhere. 6 and 0, 3 and 0, 1, 1, 1, like this. And we got this one. At the 18 digits, we again arrive at 1 from where it started. That the sequence will appear. I'll correct it slightly. I did something earlier, so that could go to this. It becomes like this. Again, I told you, it is possible to get the same result from right to left by sharing, by starting with the same numerator and multiply with 2 and adding the carry part left in small form. That is 1 into 2, 2 into 4, 2 into 8, 2 into 6 plus 1, 2 into 3 plus 1. Please see up this way. I told you. In case of full cycle like here, digits of one half length are 9's complement of the digits of the other half length. The half lengths are divided like 2 half lengths are there. One is from here to here, another is from here to here. One is from this 0 to 8, another is from 9 to 1. And this is thus, after evaluating 9 digits, we could have gotten the rest by subtracting from 9. Please see above, this can be done. This part is clear? This slide is understood?
People should react whether they have understood or
Yes,
not.
sir.
Yes,
Yes. It's actually brilliant.
Now, I was discussing and got disturbed. Discussing denominator 9, we got a full cycle. It's very easy to get the result for other numerators. For example, in case of 9 by 19, the starting digit is 9, and we can follow the same procedure as previous, either division or left to right or multiplication to right. But since we know the sequence, this is there, along with remainders already, just by below observation, we get 9 by 19 as 0.47. See, 9 was here, isn't it? 9 was there without any remainder. So when I do it for 9 divided by 2, we get 4 and remainder 1. So the same thing we'll get. So it becomes 4, 7, see here. 4, 7, 3, 6, 8, 4, 2, 1, 5, 2, 6, 3, 1, 5, 7, 8, 9, ends in 9. So 9 by 19 will end in 9. So this way, see, and start with 4. The next to 9. So that way you just guess. Some of you can please guess here. 4 by 19. Please do somebody guess for 4 by 19. What is the starting point and what is the ending point?
0.7368.
Any other answer?
There is a disturbance, audio disturbance. Please switch off. Please mute yourself. There's audio disturbance. Okay. Thank you.
Some more answers, maybe please. 4 by 19. 4 by 19, it is not clear here. So this is the full sequence actually, along with remainder. You please tell me what is 4 by 19.
0.201.
0.201.
201.
No. These zeros are remainder. These zeros are remainder. So 4 by 19 is what?
Mm.
0.7368421.
No. That's what this is the catch here.
No, it should start with the 2, sir. I mean 0.21 because remainder should be 0.
6316.
Yeah.
What one?
0.210 526316.
Exactly. That way. It is in the last of the cycle. See,
Yeah. So 6 becomes first.
It becomes 0.2.
Yeah, 0.2.
4 by 19, it will be 0.2. 0.21 and then 0.52631157890, and it will it will end at this 4 with remainder 0. This 4. But suppose I ask you 14 by 19, then what is the starting point? 14 by 19.
0.7.
Tell me on the 6 digits. At the 6.
0.736842105 and it continues.
Exactly. So you understood, na? You'll be able to do it. So that way you can guess for. As your homework to press check, guess for 7 by 19, 11 by 19, 18. 19.
Sir, can we do by 3 digits also? 1 digit divided by 3 digits in the same fashion.
No, gradually I am approaching. No.
Okay.
Only 1 by 19 is there. Now I have discussed about 1 by 29.
Correct. No, I'm meaning 1 by 119 can we do?
Yes, why not? Same. But only to find the digit divisor. See now gradually you are progressing, so you understand it. So now we come to 1 by 29.
Yeah,
See the denominator ends in 9. The digit divisor will own more than one previous. Previously, previous of 9 is 2 and more than 1 is 3. So also therefore digit divisor is actually d plus 1 divided by 10 is 29 by denominator plus 1 divided by 10, which is 3. Divide 1 by 3.
Then it should be dd plus 1 maybe, no? For 3 digits.
Please see Murthy garu, please be patient. He is going step by step.
Okay.
Please.
Acha. Now this is actually 3. So digit divisor is 3. So divide 1 by 3. Now I again go to white screen, and you tell me what to do about. Then you come back to this one. So 1 by 29. What I have to do? Divide by what? I told divided by what?
You said 3.
Because 29 plus 1 is to 30. 30 by 10 is 3. Or the 2 plus 1 is 3. That's directly. So this goes to. So I have to start with this 0. Start 1 by 3 in a special way. Tell me 1 by 3 special way. So obviously my first quotient will be 0 and remainder 1. Remainder 1.
3.
Now divide by 3. 10. 10 divided by 3.
Yeah. 3 and 1.
3 and 1.
So 13 divided by 3. So 4 and 1. Now we get 2, sir. We get 4 and 2.
4 and 2.
Oh, we can write 2. Okay.
8.
24.
8.
2 and 2.
2 and 2.
2 and
7 and 1.
7 and 1.
5 and 2. 6 and 1. 8 and 1.
8, 5 and
8
2.
and 1.
8 and 1.
8 and 1. 6. Then 2. Then again 6 and 2.
Hmm?
6 and 2. 3, 6 are 18, 2 remain. Again 6 with a 2 remainder.
0 with a 2 remainder.
So 2 divided by 3 is 0 and 2 remainder.
How can you explain how, sir? 2 is there, so how is it 2? How is it 0?
When you divide 2 by 3, my quotient becomes 0.
Okay.
And remainder 2. Okay. Sorry.
6 and 2.
6
6
and
and 2. 2.
6 and 2. Yes.
8 and 2. Is it starting to repeat? No.
8 and
2.
9 and 1.
3 and 1.
6 and 1.
3 and
6
oh yeah,
and
6 and 1.
now see, we can continue like that, but we do a slight trick. With 1 by 19, total digits are 28. 19 minus, 1 by 29. Total digits will be 28. So it is 28 divided to 14. 1, 2, 3, 4, 5, 6, 7, 8, 19, 11, 12, 13, 14. Now you simply divide, subtract from 9. So it directly will do like that.
Can you explain why you started doing it like this now?
You can do it. You do it, you will get the same results.
No, you see, the point being explained is that 1 by 29
Okay.
is the start point. So
Okay.
29 minus 1 is 28. So
Okay.
you will have 28 expressions, digits, 28 into half, I mean half is 14.
Okay.
So you start from point
Oh,
0,
cycle.
3, 4, 4, 8, 2, 7, 5, 8, 6, 2, 0, 6, 8. That becomes 14.
Okay.
After
Okay.
that 14, if
Okay.
you just subtract from 9, you will get all the digits. 9 minus 0 is 9, 9 minus 3 is 6, 9
Oh.
minus 4 is 5, and so on so forth.
Okay. Okay. Dhanyavad.
This is a shortcut method.
Excellent. Dhanyavad.
But actually, you miss one thing. Actually, this is not always good. You miss one thing that you are not missing the reminders. You are missing the reminders. Mind it.
Yeah.
So
Reversing is difficult.
huh?
So calculating it back is difficult because the reminders are not written.
Yeah, exactly. So I come back to the actual one, and you just have an idea of the procedure. See, here I do. What you did from there, it is already written here, along with reminders. So this way, the successive Q and R combinations of R by Q becomes, we already did ourselves, 0, 3, 4, 5, 0, 6, all these things, 9, 1, all these remainder, thereafter again repeats. Just 1 by 29 is the whole thing, recurs after 28. For 29, the recurrence length is again full cycle. Now again you can guess, say, suppose you are asked to do 18 by 29. Please tell me, what is the starting point? 18 by 29.
0.620 68916
Yes, exactly.
We'll have to count the number of digits and
Exactly.
reverse it.
Acha. And say 7 by 29.
It is towards the end. 0.241.
0.2413. All are also doing this thing now. Everybody is understanding 0.2413 and so on. Again, can you match that? It is the right to left method is also working. So start with 1 by 19. Start with 1. See, even right to left method you can do. Suppose we start with, say, I want to do a 18 by 29. Okay, so 18 by 29. If I want to start, I start with this one, isn't it? 18 by 29. I start with here.
No, we are not able to see what. We are not able to see.
I put a dash.
Underlined in red.
Underlined in red. So 18 by 9. See, 18 by my 18 by 29 would have been already told that's 0.6206 and so on after 18. But if suppose I have to do now right to left from 18 by 9. Independently I want to calculate. So what do you do? 18 by 29. So I do 8 into 3 plus 1 is 25. 5 into 2 plus 5 into 3 plus 2, 17. 7 into 3 plus 1, 22. 2 into 3 plus 2, 8. That way it goes back. From here back, it goes back to here. 0 into 3 plus 1 is 1. 1 into 3, 1 into 3, 3 into 3, 9. 9 into 3 is 27. 7 into 3 plus 2 is 3. It goes. And finally, it ends up here. This is also another procedure I told from right to left. From right to left or 18 by 29, we can do this way also. Is it clear? So
Can
there
you
are three.
repeat this part? Can you repeat how you're going backwards? What are you multiplying by?
See, for 1 by 29, I have to start with 1 always.
Okay.
1, we start multiplied by 3, multiplied by 3. 1 multiplied by 3 is 3. 3 multiplied by 3 is 9. At the end, 9 into 9 multiplied by 3 is 27. 7 I put and 2 is remainder, and a carry. In this case, we should not call remainder, but tell us carry. 7 into 3 plus 2 is 23. So 3 into 2, 3 into 3 plus 1 is 11, and plus 2 is 11, and that way. But in case of 18, I started with 18, and which is 8 actually. 8 as a put digit, we put last digit, but 8 into 3 plus 1 is 25, and 5 we put, and 2 is carry. So
5 into 3 plus 2. 5 into 3 plus 2. Yeah. Okay. Got it.
So when I have this sequence, this is the whole, this sequence itself, it becomes an asset. Once if I calculate, only once, the whole sequence of this, my quotient and remainder, becomes my asset for calculating all the different ways, for all the fractions from left to right, right to left, and nine complement, everything I can do by right once for all. So, but suppose you are given 1 by 29 in the conventional way, you do it again. Suppose somebody again give you 5 by 29, again evaluate. Suppose next time somebody gives 21 by 29, again you have to evaluate from the beginning, all big steps. But here, everything is at your glance and everything is known there and there.
Denominator being the same, you can find.
Denominator being the same, all these things becomes, all the fractions involved, if you evaluate it in one go.
Okay.
In a way. Now, there I already discussed this thing. 1 by 29 2. They're starting from this kept and multiplied by this thing. 1 by 29 is a full recurring cycle. You can guess the other denominators. This whole sequence, along with actually here the remainders are not there. Along with remainder, it will become easy. And then 15 by 29 is this. I discussed this thing. Now guess for, you can take as a homework. My PPT is there. All these things you can, as a homework, all these things you can take.
Okay.
Now come to Vedic online method, continued, N by A9.
Gautamji, we are at 8 o'clock now. Can we do it today or tomorrow?
Okay.
So I think you have given good homework.
A dump from my Excel sheet. You can, yes, you can do as a homework. In case of 59, it will be 6. 5 plus 1 is 6. Yes, I can stop today, but for tomorrow, you can just put tomorrow's thinking. I just put it. There is a algebraic background here. This we'll discuss tomorrow. But what happens to other D? Like 1 by 17, 1 by 7, not 9. So it becomes 7 by 49. I have to somehow put this, get the 9 at the end. So 7 by 49, if I do, the same way I can do. So 7 divided by 5, I do, 1 by 7 becomes this and that way. So 1 by 13, I have to do 3 by 39. Okay. So that way I have to always put this 9 at the end. So this way I have to do. And thereafter, different other issues are there. Tomorrow we'll cover that. Okay, thank you. Namaskar for today.
Okay, thank you, Goutham ji. Now, okay, thank you. Now, shall we do Prarthana, because already 8:10 now. We will do Prarthana and then Janaganaman.
Sure. स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पौत्रिणः अधनाः सधनाः सन्तु जीवन्तु शरदां शतं सत्यं वद धर्मं चर स्वाध्यायान् मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः सर्वे जना सुखिनो भवन्तु लोका समस्ता सुखिनो भवन्तु स्वस्ति
Dhanyavad. So let us recite from the Janaganamana.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हे
Jai Hind.
जय
ధన్యవాదములండి చల్ల చిట్టి బాబు గారు.